Hey guys, so we are going to learn some new equations today. They're going to work similarly to the sum and difference formulas that we learned last week, right? These are our half-angle formulas, and they are going to allow us to solve for more trig values that we didn't have the skills or the tools to solve for without a calculator before, right? So we do have three new formulas, right? We have a half-angle formula for sine. And our half-angle formula for sine says that if we have sine of u over 2, and that u can be a radian measure or a degree, but if we have sine of u over 2, it's equal to plus or minus the square root of 1 minus cosine of u over 2. All right, now we have a really similar equation for cosine. So we have our half-angle formula for cosine, which states that if we have cosine of u over 2, it's equal to plus or minus the square root of 1 plus cosine of u divided by 2. Right, and the last half-angle formula we have is for tangent, and that states that if we have the tangent of u plus, not u plus, u over 2, right, that's going to be equal to 1 minus cosine of u over sine of u, right, which is also equivalent to sine of u over 1 plus cosine of u. Right, now if you notice in the half-angle formulas for sine and cosine, they do have a plus or minus outside of the square root. Right? And that's because we know whenever we take the square root of something, our answer is always the positive or negative version. Right? For instance, the square root of 9 we know is 3 or negative 3, right? So we decide whether we're going to use a positive or negative depending on which quadrant our angle or radian measure, the u over 2, falls in. Right? If it's in quadrant 1, sine and cosine would both be positive. But if it was in quadrant 2, for instance, cosine would be negative and sine would be positive, right? And then we know how the rest of them work. If it's in quadrant 3, they would both be negative. And if it was in quadrant 4, cosine would be positive and sine would be negative. Now we don't have to worry about the plus or minus for tangent, right? The formula takes care of it for us. All right, so let's go ahead and look at how we would use these equations. If you look at the example below, it says find the exact value of sine of 22.5 degrees. Well, 22.5 degrees is not one of our significant values on our unit circle, but if we were to take 22.5 degrees and double it or multiply it by 2, we know that that's going to give us 45 degrees. So what we can do is we can say, all right, well, let's rewrite sine of 22.5 degrees, but we'll rewrite it as sine of 45 degrees divided by 2. So 45 degrees is one of our significant values, so we can use our half-angle formula and solve. We're going to use our half-angle formula for sine because that's what we're trying to solve for here, sine of 22.5, right? And I'm going to plug in, wherever I have a u, I'm going to plug in 45 degrees. So my formula tells me to take plus or minus, right, the square root of 1 minus cosine of u divided by 2. Right, in this case, 22.5 degrees is in quadrant 1. And so since we're in quadrant 1, we know that sine is going to be positive. Right, and so I'm going to take the square root of 1 minus cosine of 45 degrees divided by 2. Right, now I can go ahead and start solving for this. Cosine of 45, that I know how to solve for. Right, it is a significant value on my unit circle. Right, I know that the cosine of 45 degrees is my x value at 45 degrees. So I'm going to go ahead and say, all right, well, this is all equal to the square root of 1 minus cosine x value at 45 degrees is square root of 2 over 2. And then I've got to divide this whole thing by 2. All right, well, we know, especially after all the proofs we've been doing, right, that we can't subtract 1 minus the square root of 2 over 2 until I get a common denominator. So if I go ahead and rewrite 1 with a denominator of 2, all right, if I multiply the denominator by 2, I got to multiply the numerator, right, 2 over 2. What I end up with, all right, is if I put it all over common denominator, I have 2 minus the square root of 2 over 2 divided by 2. Lots of 2's, right? All right, so from here, I can go ahead and just start simplifying. Right? In order to divide 2 minus the square root of 2 over 2 by 2, I'm going to go ahead and get rid of this divided by 2 by multiplying by its reciprocal. And when I do that, I'm going to end up with the square root of 2 minus the square root of 2 over 4. All right, and that's because we know 2 times 2 gives me that 4 right there. All right, so now we can go ahead and we can actually go ahead and look at that square root of 4. All right, we know that the square root of 4 is just 2, so I can take this one step further and I can rewrite it as the square root of 2 minus the square root of 2 all over 2. Right, and at that point, we're done. We really can't simplify this any further, right? We took the square root of 4 out of the denominator. We simplified it down to just 2. Right? We said that this was going to be positive because it's in quadrant 1. And so at this point, that is my final answer. Sine of 22.5 degrees is equal to the square root of 2 minus the square root of 2, all divided by 2. Right? Another way that you could write this, either way is acceptable. We know that divided by 2 is the same thing as 1/2. So I could write it as 1/2 times the square root of 2 minus the square root of 2. Both of these are equivalent. Okay, it just depends on your format. All right, so let's do one more example so that way you guys can see one more before you start working on it on your own. All right, if we were to look at our next example, we have cosine of 112.5 degrees. We know that 112.5 is not one of our significant values on the unit circle, but if we were to double that, we would have 225. So I could rewrite this as cosine of 225 degrees, which is a significant value on our unit circle, divided by 2. All right, and so this is essentially my cosine of u divided by 2, where u is 225. All right, here's my u. So I'm going to go ahead and just kind of plug this into my half angle formula. Right, now my half angle formula states that I'm going to take plus or minus the square root of 1 plus cosine of u over 2. All right, remember, we decide whether we want a positive or negative based off the quadrant. All right, now 112.5 degrees is in quadrant 2. All right, cosine is our x value, and in quadrant 2, our x value is negative. So for this one, we're going to write a negative square root of 1 plus cosine of u, which in this case is 225 degrees, divided by 2. All right, we know how to solve for cosine of 225 degrees. We want our x value at 225. All right, so in that case, it is going to be cosine of 225 is negative square root of 2 over 2. So I'm going to say 1 plus negative, and then instead of writing that plus negative, I'm going to go ahead and just write it as 1 minus square root of 2 over 2. And then I divide all of that by 2. All right, once again, we are going to want a common denominator in order to do the 1 minus square root of 2 over 2. So I'm going to change that 1 to a 2 over 2 and combine it to the square root of 2 minus the square root of 2 over 2 divided by 2. All right, put it over that common denominator. All right, now to get rid of that double fraction, I'm going to go ahead and multiply by the reciprocal of 2. So I multiply by 1/2. And once again, I'm going to end up with the square root of, oops, I haven't been putting my negative, I should have. So negative square root of 2 minus the square root of 2 all over. And remember, this 2 times 2 is what gives us the 4. Right? When we multiply fractions, we multiply straight across. 2 minus the square root of 2 times 1 leaves me with just 2 minus the square root of 2. All right, and then in the denominator, that 2 times 2 gives me 4. Now, once again, I can simplify this, right, because I can go ahead and I can find the square root of 4. Right, the square root of 4 we know is just 2. So I end up with negative square root of 2 minus square root of 2 all over 2. And that becomes my final answer. I can't take that any further. Okay, I am all done. All right, we'll do one more example so you guys can see tangent, and then I'm going to let you guys start working on some of your own problems. All right, so the next problem we have is tangent of 15 degrees. 15 degrees is not on our unit circle. It's not one of our significant values, I should say, on our unit circle. But we know if that we double 15 degrees, we end up with 30, which is a significant value. So we'll go ahead and rewrite tangent of 15 as tangent of 30 divided by 2, where u equals 30 degrees. So if we plug it into our formula, we end up with 1 minus cosine of 30 divided by sine of 30. Right, now we can just start solving for this. We can break it up piece by piece. Right, we know cosine of 30 equals square root of 3 over 2. Right, and we know that the sine of 30 degrees is equal to 1/2. Now we just need to simplify. If we change that 1 and give it a common denominator of 2, we end up with 2 over 2 minus the square root of 3 over 2, all divided by 1/2. Right, we notice all of these have the denominator of 2, and we know that those will just end up simplifying out. So we're just going to be left with 2 minus the square root of 3. Once we simplify out those denominators, right, we've really done all the work we need to. 2 minus square root of 3 is simplified as far as we can take it, and that becomes our answer. Right, tangent of 15 degrees is equal to 2 minus the square root of 3. All right, now what I'm going to have you guys do is I'm going to have you guys go on Blackboard, and you'll see a half angle formula assignment, and I want you guys to practice these as well. Do your work in your notes, answer your final answers, of course, in Blackboard, and you will have 2 attempts, so if you have any questions, feel free to email me, and I can help you out.